Alright, so this is Geometry Chapter 7, Section 1, Ratios and Proportions. So, first thing first, what's a ratio? A ratio is a comparison of two quantities by division. A comparison of two quantities by division. Two or more, but in this case it's going to be two for right now. Okay, you could write them in a couple of ways. So if we have some number A and some number B, one way to write a ratio, and this is the most common way, is to do it as a fraction, A over B. You can also say A to B, where the numerator is first and the denominator is second. Or you can write it A to B with the colon, again where the numerator is first and the denominator is second. Okay. So here it says we have a bonsai tree with a width of 18 inches. And it's 2 feet tall. And 2 feet is 24 inches. And they want its ratio of width to height. So since it's width to height, the width is going to be in the numerator, which is 18 inches. Height's going to be in the denominator, which is 24 inches. Ratios are primarily unitless, meaning that there's no units, so the units are going to cancel. The inches goes away. And we have 18 over 24, which can be simplified by dividing by 6, which gives me 3 to 4. So my ratio is 3 to 4. It says the measure of two supplementary angles has a ratio of 1 to 4. What's the measure of their angles? So since my ratio is 1 to 4, we're going to let 1x be 1 and 4x be 4. And since they're supplementary, they add up to 180, so it's going to be 1x plus 4x, which equals 180. So that's going to be 5x equals 180. Divide by 5. And I get x is equal to 36. Alright, so then the ratio of these two, or the angles, is going to be 1 times 36 and 4 times 36. So that's going to be 36. That's one angle. So one angle is 36 degrees, and then the other angle is going to be 144 degrees. And when you add those guys up, 36 and 144, you should get 180, and you do. Here we have a triangle, just a random triangle. And it says that it has something called an extended ratio. So when we have an extended ratio, It's when you have three or more quantities that you're comparing. Three or more quantities that you're comparing. So in the case of the problem, it says we have a ratio of 4 to 7 to 9. So 4, 7, and 9. And it says it has a perimeter of 60. So when we set it up, we're going to use an extended ratio and say the sum of the sides equals 60. So 4x plus 7x plus 9x equals 60. Combine them. 13 and 9, that's 22x. Let's see if that's correct. No, it's not. 4 and 7 is 11. So that's 20x, sorry. X equals 3. Since x equals 3, I'll plug in the 4 times 3, which equals 12, 7 times 3, which equals 21, and 9 times 3, which equals 27. So these are the lengths of the sides of a triangle with a ratio extended of 4, 7, and 9. And when I add them up, 12 plus 21 plus 27, I should get 60, and I do. Okay. A proportion are two ratios that are equal. Alright, two ratios that are equal, and I'm going to use the example in the book. So you have a 2 over here, you have a 6 over here, decimal, or colon. We have a 3 over here and a 4 over here, and they're equal. The outside terms, the first and the last terms, these guys are called the extremes. The first and the last terms are called the extremes. The inside terms are called the means. The inside terms are called the means. Right. The extremes are the first and last terms, and in the middle inside terms, these are called the means. When we set them up as fractions, these guys over here are the means. These guys here are the extremes. So we set them up usually as fractions, and which leads us to cross products property or cross multiplication. When we have a proportion, and you guys have been doing this for a while now, that's D. The product of the means is equal to the product of the extremes. So that means what that AD is equal to BC. Okay. The product of the means equals the product of the extremes. That's the cross products property that you can cross multiply. Here is the proof. So we have A over B and C over D. I want to get rid of the denominators. In order to get rid of the denominators, I got to multiply it by some number such that the numerator is going to be the product, B and D, of the denominators. Same thing goes over here. Alright, so then when I multiply this, I'm going to have A times B times D on this side over B. And I'm going to have C times B times D over D on this side. The D's cancel. And I have AB and I have CB. And this is the cross products. AB equals CB. AD equals CB. Alright. Cross multiply to solve some stuff. Here we have 9 over 2, and that's equal to A over 14. I can cross multiply and get 2 times A is equal to 9 times 14, which I think it is 126. Divide by 2. A equals 16. 3. A equals 63. I can cross multiply here. 15 over m plus 1 equals 3 over m. Cross multiply 5m equals 3m plus 3. Subtract 3 from both sides. Oh, 15. 15m equals 3. Subtract 3 from both sides, and I have 12m is equal to 3. M is equal to 4. Right, you guys have cross multiplied before. Alright, properties of proportions. There's 3 of them. Property number 1. If I have a proportion, I can do the inverse or the reciprocal of both of the fractions. So I'm going to switch the sides. So now B is going to be on top. A is going to be on the bottom. B, C, I don't know why I keep doing that. D is going to be on top. C is going to be on the bottom. These guys are equivalent. These guys are equivalent expressions. They're the same. If I cross multiply this guy over here, I get AD equals BC, the same. If I cross multiply over here, I get AD equals BC. See, they are the same. So the reciprocals of each one of the ratios are equivalent proportion. Alright, so for A over B equals C over D, if I was to switch the means So A over C is equal to B over D. These guys are the same. A over C is equal to B over D. Again, they are the same. If I cross multiply, I still get AD equal to BC. I cross multiply, I get AD equal to BC. So these guys are the same. So I can switch the extremes. Up top, I can have the reciprocal. Okay. And then lastly, if I have A over B equal C over D, that's the same thing as saying A plus B over B, which is equal to, start this over, A over B equal to C over D is equivalent to A plus B over B and C plus D over D. So in essence, I added the denominator on both sides. So I add, the denominator is B, I added up top. The denominator is D, and I added up top. And these guys are equivalent. One way to check that out to prove it, you could cross multiply, and that would be AD plus BD is equal to CB plus CD. Let's see, AD, BD, BC plus CD. Let's see. B times C and BD. Okay, BC, BD. These guys cancel. So then I'm left with AD equals BC. So it works. I still end up with the same thing. There's another way of thinking about it, but I'm not going to rack your brain on that one. Okay? So I can do that as well. These three guys, let me say, add denominator to the numerator. All right, these guys are all equivalent expressions. We are proportions. Okay, the reciprocal. Switch the extremes. Add the denominator to the numerator. All right, so for here we have a x over 6 equals y over 7. And then for a, they say, okay, if it's 6 over x, what's the next part? Well, if I see 6 over x, the 6 went to the numerator, x went to the denominator. So this is property number 1, where it's the reciprocal. So it's going to be 7 over y. Then for b, we have y plus 7 over 7. So they added the numerator to the denominator. So for this side, it's going to be x plus 6, which is the denominator, over 6. All right, so that's property number 3. Alright, so that's at that section. Have a great rest of your day.